Ever get the feeling that talking to voice assistants is kind of like, well, talking to a robot?
Uh-huh. Yeah, I know what you mean. A little lacking in the personality department.
Exactly. But, a lot of folks are working on making those interactions more natural, more engaging. And that brings us to today's deep dive. We're looking at something called Sesame CSM,
CSM.
conversational speech model from the folks over at Sesame.
Ah, okay. So we're digging into how this new model is pushing the boundaries of digital voice then.
That's the mission. We want to get to the core of what makes it tick and why it matters in the always evolving world of voice tech.
Sounds good. Where do we start?
Well, right off the bat, what struck me was Sesame's focus on something they call voice presence.
Voice presence.
Yeah, it's not just about the AI getting the words right, it's about making it feel like it actually gets you, like it understands.
So going beyond just transcribing and spitting back words, more like a genuine back and forth.
Exactly. And they're making the point that the old ways of evaluating how well AI understands context, well, they're not really cutting it anymore.
Hence the need for models like CSM.
Right. So, what exactly is at the core of this CSM?
At its heart, it's an end-to-end system. Learns from both text and audio, all at the same time.
Interesting.
And it uses the same transformer architecture that's powering a lot of the big AI breakthroughs these days.
Ah, so it's leveraging that tech.
But the real key here, the big leap, is that CSM considers the whole history of a conversation, the entire back and forth.
For real.
Yeah, and that allows it to make its speech much more contextually coherent, like it's actually following along.
So it's not doing this in stages like some other systems. It's all happening at once.
You got a single-stage model, which can lead to more efficient, more expressive speech.
Hmm.
And the way it works, it converts both the text and any incoming audio into, well, they call them Mimi audio codes.
Mimi code.
Yeah, using a technique called residual vector quantization, RVQ.
RVQ.
Think of those Mimi codes as like super efficient digital snapshots, capturing all the nuances of human speech.
Okay. Interesting. So where does the AI actually understand the language then? Like, how does it process the meaning?
That's where a large language model, or LLM, comes in, based on Llama, actually.
Llama. I've heard of that.
Yeah, it's a pretty powerful one.
Yeah.
That LLM is responsible for, well, the language understanding part, picking up on all those subtle cues in a conversation.
So it's like the brains of the operation.
You could say that. And then there's a separate audio decoder, takes the LLM's understanding and turns it into those Mimi codes.
Which then generate the actual sound.
Exactly.
So context is king for CSM.
Oh, absolutely. CSM can adapt its tone, its speed, based on what's already been said.
Wow.
And get this, it can actually process both text and audio simultaneously.
No way. At the same time.
Yeah. Gives it a much richer understanding of what's going on in the conversation.
That's impressive.
One thing to keep in mind, though, CSM's main focus is on creating audio, not generating text like some other AI models out there.
Right, right. So how does it manage to achieve that human-like sound? What makes it sound so natural?
They've got this clever dual token approach going on with those RVQ audio codes.
Oh, okay.
So there are semantic tokens for the words themselves, and then acoustic tokens. Those capture like the unique characteristics of a voice, how high or low it is, the rhythm of speech, what we call prosody.
Makes sense.
And this lets them fine-tune those subtle variations. Even things like sounds and even simulated laughter.
Oh, wow.
Yeah, it can even replicate someone's voice if you have a recording.
So voice cloning is on the table.
It is.
Pretty powerful stuff. Are there any limitations?
Well, while it can sound really natural on its own, getting the rhythm and intonation to perfectly match the context of a conversation, that's still a work in progress.
So there's room for improvement. Okay. CSM, conversational speech model. It's all making sense now. What makes this tech really stand out from other voice tech out there?
Well, for one, it's that end-to-end multimodal system.
Yeah.
The whole package.
Right.
And the single-stage processing makes it super efficient.
Right.
And how it models prosody based on context, the ability to handle both text and audio inputs, and those Mimi codes. It's all significant. But maybe the biggest deal is that Sesame made it open source.
Open source, that's a game changer.
It is. Puts this advanced voice synthesis tech into the hands of way more researchers and developers.
Democratizes it.
Exactly.
So what's going on under the hood, technically?
Okay, so it uses two autoregressive transformer networks. Builds on the architecture of RQ transformer, if you're familiar with that.
So I have to look that up.
There's the Llama language model, which comes in different sizes.
To suit different needs.
Right. And then a smaller network just for creating the audio. The Mimi audio codes, they're really efficient, good sound quality at a low data rate. And they trained it on like a massive amount of public English audio data with transcriptions. Think about it. Over a century's worth of conversations for the AI to learn from.
Wow, that's a lot of data. What about the hardware requirements?
Surprisingly accessible. It supports standard GPUs. They even have efficient versions that can run on less powerful machines, including Apple Silicon.
So not just limited to, like, supercomputers.
Nope.
How does CSM fit into the bigger picture of AI voice tech? Like, where does it stand in the landscape?
Well, large language models, LLMs, have really pushed what we call zero-shot TTS forward.
Euroshot.
Yeah, where the AI can generate voices it hasn't specifically been trained on.
Ah, I see.
A lot of systems do this in multiple stages. But CSM, with its single-stage approach, could be way more streamlined.
Makes sense.
And we're seeing exciting stuff from, the big players, Google, Amazon, Microsoft, research labs too, OpenAI, 11 Labs, the list goes on.
It's a hot field.
It is. But what makes CSM really stand out is that open source nature. It's a unique resource for the research community.
So to sum it up, CSM offers context-aware speech, efficient end-to-end design, and it's open source. What's next for Sesame? Where do they go from here?
They're looking to scale up the model, include more languages, more data, and further integrate large language models.
Even more so.
Yeah, their long-term goal. Creating AI that can have truly natural two-way conversations.
Like indistinguishable from a human.
That's the dream.
Wow. That's some pretty mind-blowing stuff. So for everyone listening, think about this. As AI voices become more and more realistic and they really start to grasp the nuances of conversation, how will that change how we interact with technology every day?
That's the question, isn't it?
It is. It's definitely something to ponder as this whole field keeps evolving. Thanks for joining us for this deep dive.
Thanks for having me. It's been great chatting about this.
Until next time.